Hi guys, welcome back to my YouTube channel. In today's video, we're going to be integrating using partial fractions. This video is going to be pretty short because I want to take this step by step since I had struggled a lot when I was learning to solve using partial fractions. So if you guys need harder examples, you can leave them in the comments and I'll make a new video on that. And I remember I said last video that I was going to do another related rates video, but I don't think anyone really struggled with that. So if you guys still need a video with harder examples, then let me know. I'll be sure to upload that as well. So let's get started. Okay guys, so we're gonna start this question off by using long division. Okay, we're going to use long division to solve this question, and then when we get the remainder, the factors and everything, when we get everything, we're going to use remainder theorem to write it, and then we're going to integrate it using partial fractions. So I'm going to start writing that so it's easier to visualize. Okay guys, so I'm sure we're all old enough to know how to do long division, so I'm not going to explain it much, but I'm going to directly go ahead and solve this. So we are going to find a factor that will multiply to this and equal to this, and when we minus, we get 0. So let's do x. X times x squared is x cubed. X times negative 3x is negative 3x squared. And 2 times x is 2x, and then we minus everything and see what our remainder is. So I'm going to write that down really quickly. Okay guys, so I quickly wrote it out and canceled what I could cancel. So x cubed minus x cubed is 0. Negative 3x squared minus negative 3x squared is 0. X minus 2x is negative x. So our remainder is negative x. Now we're going to use remainder theorem to write this out. So the way we use the remainder theorem, I'm sure you guys already learned this, but is the factor plus the remainder over what we divided by. So I'm going to write that out really quickly. Okay guys, so here I wrote it out using the remainder theorem. Now, what we basically did is we just simplified the integral. We still have to integrate this. So we have to integrate these separately. The integral of x is x squared over 2. I'm writing with my left hand, I'm sorry if it's messy. X squared over 2 plus the integral of negative x over x squared minus 3x plus 2. And the way we're going to do that is we're going to separate this over here, and I'll show you how we solve it. Hey guys, so I brought this up here, the integral of this, we're going to integrate this. So the first step we want to do to integrate this is factor the denominator. You're going to see why this is necessary in a few seconds, but we're going to factor the denominator, so go ahead and do that. Keep everything else the same. Okay guys, so now that I've factored the denominator, I kept everything else the same. I factored the denominator. So the next step is we're going to suppose that the numerator is a and b depending on the denominator. Here there's two terms, so we're just going to do a and b. If it was x minus 2, x minus 1, x plus 1, we would do a, b, and c. But since it's just two terms, we're going to use only a and b. So what we're going to do is do a over x minus 2, sorry, my left hand writes really bad, plus b over x minus 1. And for this, we're going to be using something called the cover-up method. So now that we wrote it out like this, we're going to be taking the non-permissible value for each term and find out what a is. We want to find out what a and what b is. So I'm going to write that out. What we're going to do is find the non-permissible value of a. What makes the denominator of the first term 0? 2, right? If we plug in 2 into x, then the whole denominator turns 0 and it becomes undefined. So we're going to cover this, plug in 2 into the numerator and the denominator, and find out what the value for the whole equation is. Sorry. Find out the value for what a is. So negative 2 over 2 minus 1. Okay, we're going to do that. I'm going to write it out more cleanly. So I wrote it more organized. So what I was saying is that the NPV, the non-permissible value for a is 2, because if we plug in 2, the denominator turns into 0, and the whole term becomes undefined. So we covered up x minus 2 because it's called the cover-up method. So we cover up x minus 2, plug in 2 into the x values, and find out what a is. So negative 2 over 2 minus 1 equals negative 2, which means our a is negative 2. Did the same for the b. The non-permissible value for this equation is 1, because if you plug in 1, it turns undefined, making the whole equation undefined. So we covered up the x minus 1 term, and we plugged in 1 into the x values. So we got negative 1 over 1 minus 2, which equals to positive 1. So our b value is positive 1. Okay, up until this part, I hope this made sense. If it didn't, then pause the video and rewatch. But the next part is really easy. What we're going to do is just substitute these values for a and b, and then integrate the final term. This is the final integration, and we'll have our answer after this. So I'm going to write it out. Okay guys, so as I said, we're going to plug our a and b values back into these and integrate these like normal. So we have negative 2, which is a, negative 2 over x minus 2 plus integral of 1 over x minus 1. Now we just integrate this like normal. I'm sure you learned in class how you can integrate something like this, and it's in the formula sheet, I'm pretty sure. So the integral of negative 2 over x minus 2 is negative 2 ln x minus 2. Once again, this is on the formula sheet, so I'm not going to explain it. And then we have ln of x minus 1. Okay, and we can't forget about when we first divided using long division, we had another term as well. We were using the remainder theorem, and we had the integral of x, which is x squared plus 2. So we need to add that to our answer as well. That way we will get our final answer. So I'm going to write the final answer now. So we finally have our answer. We have x squared over 2 minus 2 ln x minus 2 plus ln x minus 1. If you're confused where the x squared over 2 came from, I recommend you rewind the video and see where I got it from. But it was after the remainder theorem when we had the separate factor plus the remainder over what we divided by. So we can't forget this. So this is our final answer. If you have any questions, you can leave them in the comments. Okay guys, so that's it for today's video. This video was probably very confusing. So if you had any questions, you can leave them in the comments and I'll be sure to answer them. I had a lot of, I struggled a lot with partial fractions, so I understand if it's confusing. It took me a while to get it too. Also, the method I used was called cover up, and some questions require not using cover up. And if you guys need a video on that, you can let me know. So yeah, that's it for today. See you guys next time. Bye.